Okay, so this is our second part about solving trigonometric equations and triangles. And it's really following mostly the same steps. What's different for a lot of it is just the algebra, at least for this first part. And then we're going to move into something new. So, we start off just the same as we did before. We have an angle, you're trying to solve for x or something. And so, like I said before, best thing to do, boom, 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 go red, is you label or you mark the angle you're looking at, you're starting from, 25. Go across, that's opposite because it's all the way across. And x is adjacent because it's not the hypotenuse and it's right next to it. Boom. And then we think SOHCAHTOA, which hopefully you have memorized because, it is like the one thing I said you really, really, really need to know. SOHCAHTOA. And so if you know SOHCAHTOA, you know OA goes with that T, which means tangent. So tangent of 25, because it's always tangent angle, equals O over A. O is 13, A is X. So what's different here compared to usual now is that X is on the bottom instead of on the top like it usually was for that last section. So what we've got to do is manipulate this equation so that X is not there. So the first way of doing it is just to multiply both sides by X, because you always multiply because that's the opposite of dividing. And that's technically 13 divided by X. When you do this, these two X's are going to cross off. Boom, boom, boom. These two X's cross off, meaning on that side, now there's only a 13, and now it says X 25. And so now that's X times 25. The opposite of times 25 is divide by 25. And so now we get divide by 25 on both sides. In a calculator, you're going to put 13 divided by tangent 25. You get 27.9. Okay. There is an alternate way of doing this, which every once in a while people like. I don't, but if it works for you, it works for you. So we know that, we're starting with the same equation, tan 25 equals 13 over x. All I've done differently is put it over 1 because, it's a fraction. So then what you're going to do is you're going to cross multiply. Boom, x times tangent 25 equals 13 times 1. And so if you do that, you get x tan 25 equals 13, which is what we had here. And then we're going to divide both sides by tangent 25, and we get the same answer. So it's really the same thing, just some people like one way over the other, just because maybe in their memory it helps them better. There is another third alternate way of doing this, which if somebody asks me, I will show. It involves more steps though. Okay, here's something that's different, and that's finding an angle. When you're finding an angle, you're going to use what's called the inverse sine, the inverse cosine, and the inverse tangent button, which you're going to use second sine, and I get you that sine inverse, right? Or second cosine, which is the cosine inverse, second tangent, tangent inverse. And you can see those little blue, hopefully, buttons, not buttons, blue words right above the buttons. So the reason we're doing this is because, as you'll see once we get an equation written. So I can ask you to find an angle, and it looks like this. And we're going to use the same steps that we do basically for every single one of these problems. Mark the angle we're at. And some of you probably by now don't need to do that. And now just look, that's O, so that's not helping us. This 5 is adjacent, so I'm going to put the A. And then the 13 is the hypotenuse because it's all the way across from that right angle. Boom, boom. Boom. And if you look at SOHCAHTOA, AH is cosine. So we're going to write our normal equation that we've been running every single time. Cosine of x equals 5/13. So the reason we're using that inverse cosine now is we're trying to get this x by itself. And so we've got to do what the opposite of cosine is. And that's the inverse cosine. The inverse cosine gets rid of that and get the x by itself. And so you do that on both sides, and you put inverse cosine of 5 divided by 13 equals 67.4. So second cosine 5 divided by 13 equals 67.38, which rounds up to 67.4. So when you're trying to find an angle, you're always using the inverse. Angle, inverse, 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 angle, inverse. Okay, just remember, angles, you're always using that inverse. Okay, the last part of this is I might ask you, and you might be asked in other classes too, in the future, to solve the right triangle. What solving the right triangle means is I need to know every single angle and every single side. But really what you're doing is just a lot of trig. So in a question like this, they probably actually wouldn't even have given you that x and the y, to be honest. They probably would have just said solve the right, no, that's right. They would have said solve the right triangle. And they wouldn't have even given you anything. So usually what you do, it's your job to put x and y somewhere. I just put those there because I was being nice for once. Y. So the first thing is you should be able to find this angle here because we know that this is 90. Triangles add up to 180. So these two will always add up to 90. So you could always just do 90 minus 19. For some reason, I did not write that down there. So this is 71 degrees. And you have to put that. You have to have that angle. And now you're just going to find x. You're just going to start from this as usual. From this 19, this is O. This 12 is H. OH. You know SOHCAHTOA. OH is sine. So sine of 19 equals x over 12. Times both sides by 12. 12 sine of 19 equals 3.9. Now you need to find y. And if we think about it, we already have O, we already have H, so this is A. H. So it's going to be cosine. Cosine of 19 equals y over 12. Multiply both sides by 12. 12 cosine 19 equals 11.3. Now, the last thing you can do is if you really wanted to is you could double check your work. We know this is a right triangle, and in the right triangle, we know the Pythagorean theorem works. A squared plus b squared equals c squared. So I think A is 3.9, B is 11.3, and you were already given that C is 12. So you could always just 3.9 squared plus 11.3 squared equals 12 squared. The answer is yes, basically. I mean, there's a bit of a rounding that you'll have to do, but that's it. So basically, if I ask you to solve the right triangle, you're just doing multiple trigonometric equations. And then you might have to also know that triangles add up to 180 degrees.